So apparently there's been quite a bit of confusion on how to determine which equations to use during your projectile motion problems, okay? And so here's what I've suggested for students to do. Start off when you're looking at horizontal projectile motion. Let's clear up a few things first before we even look at the equations. Let's set some things straight. So let's look at any object experiencing projectile motion, and we're going to focus our attention first on the initial speed of that object and also the acceleration that the object experiences. Now with initial speed, when we're talking about projectile motion, we break our motion down into, or all of our components down into the x and y components. So we have our x horizontally and our y vertically. So initial velocity in the x, is that positive, negative, is it 0? Well, the initial velocity in the x with horizontal projectile motion is always some positive number. Some initial speed is always given. When you're talking about initial velocity or initial speed in the y component, that's equal to 0 because horizontally there's no initial speed, alright? You're just shooting straight off, or you're driving straight off, okay, or it's rolling straight off. Now when you're talking about acceleration, the acceleration in the x component is equal to 0. There is no acceleration in the x component, okay? As soon as that projectile rolls off the table, is, fired from the barrel of a gun, whatever you want to be looking at, it's going to be 0. It is not speeding up or slowing down. So that also means that the initial speed in the x component is the same as the final speed. The speed remains constant in the x component throughout horizontal projectile motion, okay? So, acceleration in the x is 0. It does not increase or decrease in speed. Now, if you're talking about the y component of acceleration for horizontal projectile motion, the y component is a specific number, and it's that acceleration due to gravity, which is negative 9.81 meters per second squared. Okay? Now, those are some things to keep in mind with initial speed and your acceleration for any object with horizontal projectile motion. Now, let's talk about choosing the equations to use. Now, check out these three equations that I'm going to be putting right here. We have, and all these equations I'm writing right now are coming from our Chapter 2, they're kinematics equations. So you have one of the kinematics equations as being your final speed is equal to your initial speed plus your acceleration times your time, alright, change in time, delta t. Another kinematics equation that we often use is delta x, your displacement in the x, is equal to your initial speed times your time plus 1/2 times your acceleration and then times your time squared. Okay? And then the third equation is your velocity final squared equals your velocity initial squared plus 2 times your acceleration times your displacement, okay? Now, these kinematics equations were set up with us on the assumption that we're always working with just one dimension at a time. But now that we're with horizontal projectile motion, we can still use these equations, but we're going to need to break them down into the x and y component and do a little bit of thinking saying, okay, do we actually need all parts of this equation? There's some things that are 0 that we can kind of get rid of. So let's look at this first kinematics equation that we wrote down here. Let's break it down into the x and y components. We'll look at the x components first. So that means I need to change all of the applicable variables into x components. So for our final speed, I put final speed sub x equals our initial speed, our velocity sub x, plus your acceleration sub x multiplied by your time. Now we don't need to worry about sub x or sub y, so I'm talking about x and y components with time, because that doesn't matter if it's x or y, okay, that's a little bit different. Now, check this out. Is there a final speed in the x? Sure, it's going to be some number. Is there a initial speed in the x? Yeah, again, that's some number. Now, is there acceleration in the x? Oh, I remember when we were talking about our objects here with horizontal projectile motion, there's no acceleration in the x. So this guy's 0. So since this is 0, 0 times 0, which I know will have some time, but 0 times 0 is still going to be 0. So this whole part of the equation is gone. So when you are rewriting this, or when you look at it, I'm going to cover up that part of the equation. It says that your final speed is equal to your initial speed. Well, we already knew that when we were talking about our object here of experiencing horizontal projectile motion. Since there is no acceleration, your speed remains constant, and that's what this equation is just showing you. So I don't think this equation is really going to be helping us much here as far as crunching the numbers. Now let's take the same kinematics equation and look at the y components. So speed final in the y equals your speed initial in the y plus your acceleration in the y multiplied by your time. Okay? Now, will we have some y component of our final speed? Yes. I know that initially we don't start off with any speed in the y, but as acceleration kicks in, you're going to have some final speed or velocity in the y component. All right, so there will be some final speed. Is there an initial speed in the y, though? Well, no, there is no initial speed, so we can get rid of this little part. Now, is there going to be an acceleration in the y? Sure, it's that negative 9.81 meters per second squared, and time is going to be there too. Okay, so we can look that there's now one potential equation we can use for our horizontal projectile motion, where our final speed in the y is going to be equal to our acceleration in the y times our time. So this is an equation you can potentially use. I don't think it gets used too often, but it is there. It is available to you. Okay? Now, check out this other kinematics equation here. Let's break it down to the x and y components. So delta x equals your initial speed in the x component multiplied by your time plus 1/2 acceleration in the x multiplied by your time squared. All right? Now, will there be some sort of horizontal displacement in projectile motion? Sure, it's being projected, all right? So there is going to be some displacement in the x. Is there initial speed in the x? Sure. Is there time? Right. Plus 1/2, is there acceleration in the x? Oh no, there's no acceleration in the x, so that becomes 0. So 1/2 times 0 is still 0. Any time squared times 0 is still going to be 0. So this whole part of our equation here disappears. So now we have another equation we can potentially use, which is our delta x equals our initial velocity in the x times our speed. So here's another equation that we have at our disposal that we can use when we're doing horizontal projectile motion problems. Now, that's the x component. Let's look at the y component of this. Delta y equals your initial speed in the y multiplied by your time plus 1/2 your acceleration in the y times your time squared. So, will we have some displacement in the y, horizontal displacement? Yes, because it's projectile motion. And most of our horizontal projectile motion problems, if you even have this problem, you've got to have the object dropping off a table, a cliff, falling down some height, okay? Will we have initial speed in the y? Well, like we talked about earlier with our objects, no. So this part is going to be 0. So 0 times your time is still going to be 0. So this guy's gone. 1/2, all right, that's just a variable, times your acceleration in the y. Yeah, we have acceleration in the y with horizontal projectile motion multiplied by your time squared. So this guy's gone, but we can still use this. So you can rewrite this equation as delta y equals 1/2 times your acceleration in the y multiplied by your time squared. So here's another equation that we can potentially use. Now let's look at this guy over here. Let's break this kinematics equation down into its x and y component. Speed final squared sub x equals speed initial sub x squared plus 2 times your acceleration in the x multiplied by your displacement in the x. Okay, so let's see what we've got here. Well, we have speed in the x component final, yes. Speed initial, yes. Acceleration in the x component, oh no, we won't have that, so that'll be 0. So 2 times 0 is still 0. And no matter what our displacement in the x times 0, that's going to be 0. So this guy's gone. So what we have here is final speed squared is equal to your initial speed squared. Well, that's a lot like what we were looking at over here that we scribbled out and said we wouldn't have any use for. So it's the same story here. Don't need that guy. That's not going to help us. Let's break this down into the y components. Your final speed in the y squared is equal to your initial speed in the y squared plus 2 times your acceleration in the y multiplied by your, displacement in the y. There we go. So are we going to have a final speed in the y? Yes, we will. Will we have initial speed? No, we said there is no initial speed in the y component for our objects experiencing horizontal projectile motion, so that's 0. Plus 2 times acceleration in the y, we've got that, acceleration due to gravity. Will there be displacement in the y? Vertical displacement? Yes, there will be. So when you rewrite this equation, it becomes your velocity final in the y squared equals 2 times your acceleration in the y multiplied by your y displacement. And that's another potential equation we can use. So these are potential equations that you can use with horizontal projectile motion, okay? So check them out. And if they're not already in your notebook, it'll be good to have there. And also, it's important to know the work. I would highly suggest that if you haven't finished your horizontal projectile motion problems, always start off by writing these 3 equations and take the time to break them down into x and y component. Yes, it takes extra time, but I promise you it will make the equation selection steps oh so much easier. Alright? So, that concludes our session with equation, manipulation, and selection with horizontal projectile motion.